Hey guys, okay, so yesterday we talked about the law of sines, which was awesome if we had two angles and the two sides opposite those angles in terms of what we were trying to figure out. The law of cosines is going to work for us when we're in kind of a different situation. So again, this will work if the triangle is not a right triangle. And if the law of sines doesn't work, the law of sines I think is easier. So that's always my first go-to. But if that doesn't work and it's not a right triangle, we can try this thing called the law of cosines. So again, I just want to make sure we remember side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And this one is scary looking, but don't panic because it looks much scarier than it actually is. And your calculator is going to be a lifesaver with this thing. So here's what the law of cosines looks like. A squared, as in side A, equals B squared plus C squared. Looks a little Pythagorean-like. Minus 2BC times the cosine of A. So I think the important thing to note about this equation is that if we are looking for side A, it's angle A that goes here, the other two sides. So we can change this up. If we weren't looking for A squared, we could look for B squared. Well, guess what? It's just A and C, and instead of A over here, because A is opposite A, B is going to go over here. So A squared plus C squared minus 2AC times the cosine of angle B. And then finally, if we wanted to write a third equation, I don't know why we would need to. I think we probably are good memorizing only one of these, as long as we remember angle, side opposite the angle are on the outsides, other two sides are in here. But if we wanted to, C squared equals A squared plus B squared minus 2AB times the cosine of which angle is opposite side C? Angle C. So there's all three versions. I love how I just wrote that and you couldn't see any of it. There's all three versions of the law of cosines, and it looks terrifying. I will give you that. There's a lot going on, but the process is actually not that bad. So let me see if I can lift this camera up and you can actually see. There we go. I don't know what I was doing before. But there we go. So let's do a couple of examples here just to make sure we've got it. Okay, so we have this first example here, find x. So side x is over here. That's what we're looking for, so I'm going to use x squared. Doesn't have an a, b, or c, so I'm going to have to apply that theorem or that law of cosines to this problem. Now, the most important thing is what's going on at the end over here. And we said on the page before that if it's side x we're looking for, then the angle that goes at this end is the angle opposite side x, which in this case is 45 degrees. And the rest of the problem just fills in with these other two sides. It doesn't matter if you want 11 first or 25 first. I'll go with 11. 11 squared plus 25 squared minus 2 times 11 times 25 times the cosine of 45. Now, your calculator is awesome if it follows order of operations because you literally can just type this entire thing in one straight shot. And I'm actually going to move my calculator over here and hope that you can see this. Let me turn this light off again. I didn't learn my lesson yesterday, apparently. Hopefully you can see this. It's not great, but it's better than nothing. So I'm just going to type this in. 11 squared plus 25 squared minus 2 times 11 times 25 times the cosine of 45. And I'm going to hit equals, and it gives me this huge number, 357. I'm going to write down all the decimals because I want to be nice and precise if I can. So that's what x squared equals. I just want to figure out what x equals. So all I need to do now is take the square root of both sides. And I'm going to get my x value. So I'm actually going to do second. There's my radical. And I can either type that whole thing in. I might be able to arrow up, hit enter, and it'll put it in there for me, which is kind of nice, so I don't have to spend the time typing. And I get about 18.9. So there's the value of x right there. Sometimes I actually think the law of cosines is easier than the law of sines because it's just one straight shot in the calculator, but it's scary to look at sometimes. Okay, let's jump to the second example. We're just going to do one more just like this so that we can make sure we know what we're doing. And once again, we're going to find the value of x. We're going to round to the nearest 10th. So I'm going to locate x. It's right here. That means x squared equals, remember the most important part, if I'm trying to find angle x or side x, the angle opposite is what's going to go at the end of my equation. So cosine 62. And then I can fill the other two sides in whichever order I want. 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 62. Sorry about that giant space there. So now that I've got it all set up, I'm going to go back to my calculator and I'm going to type all this in. So here we go. 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 62. And that's about 38.709599248. And just like with the last one, the last step, this is what x squared equals. I want to know what just x equals. So I'm going to take the square root of both sides. Back to my calculator I go. Second radical. Oop, sorry. Arrow up. I'm going to hit enter. Enter again, and I get about 6.2 for that missing side. So you got some choices now. You might notice that with both of these law of cosine examples, the info we were given to start was a side, an included angle, and a side. That's when the law of cosines is going to serve you very well. If you're given a side, an angle, and a side consecutively, and you're trying to find that third side, if you're not given those three pieces of information, you're probably going to go back and use the law of sines. But I'm going to try and find a couple of other YouTube videos that are not my voice and maybe some more visual explanation, and I will link those here in the classroom page too, so you can check them out. But give these a shot, and I'll talk to you tomorrow. Bye, guys.